class. Today we will be doing chapter 5.2, number theory in the real number system. We'll be looking at integers and the order of operations. Our objectives today are to define the integers, graph the integers on a number line, use symbols like greater than and less than, find the absolute value of an integer, perform operations with integers, and use the order of operations agreement. First thing we need to do is define an integer. The set of the natural numbers 0 and the negatives of the natural numbers is called the set of integers. So if we look at the integers here, they are basically all negative whole numbers, all positive whole numbers, and 0. So we're looking here. It starts ... -4, -3, -2, -1, 0, 1, 2, 3, 4, ... We have negative integers and we have positive integers. Notice that the term positive integers is another name for the natural numbers. The positive integers can be written in two ways. We can use the plus sign, for example, +4 is +4. Or we can just not write the sign. It says, or number 2, do not write any sign. For example, 4 is also just +4. Now if we see the number line is just a line here with numbers graphed on it. The number line is a graph we use to visualize the set of integers as well as the set of other numbers. We have negative numbers, 0, and positive numbers. 0 is neither positive nor negative. Now we can graph integers on a number line. We want to graph A, B, and C. Here, A is -3. So what we would do is we would come over here to our number line. We would find -3, and we would place a dot on top of -3. You can see they do that directly on the line. That is fine as well. We can also come over here to 4. I'll plot mine above the line. You can plot yours directly on the line if you'd like. I'm going to put a dot above 4, and as you can tell, that is the correct answer there. And then I'm going to put a dot at 0 as well, because that is what C would like us to do. Put a nice solid dot on top of 0, and as you can see, we have -3, 0, and 4 plotted. Now, we're going to look at using the symbols less than and greater than. If we look at the number line, -4 and -1 are graphed below. So we see we have a dot here at -4, and we have a dot here at -1. Observe that -4 is to the left of -1 on the number line. That means that -4 is less than -1. Also observe that -1 is to the right of -4 on the number line. This means that -1 is greater than -4. So -4 is less than -1. -1 is greater than -4. The way that I teach it in simple terms is the simple way they taught it in kindergarten and first grade. The alligator mouth opens to the larger number. Okay, so if you have the sign here, this is the mouth. Here's some teeth if you need some teeth for your alligator. It's going to open and choose to eat the bigger prey every time. So that's why it opens towards the -1 here. And even if you put the -1 on the other side, it's then going to open that direction as well. The symbols less than and greater than are called inequality symbols. These symbols always point to the lesser of the two real numbers with the inequality statement when the inequality statement is true. -4 is less than -1, just as we demonstrated before. The sign opens towards the -1, so -4 is less than -1, and -1 is greater than -4. The sign opens towards the -1 still. Use the symbols less than and greater than. Insert either less than or greater than in the shaded area between the integers to make the statement true. So here we have -4 and 3. We're going to open it towards the bigger integer, so we're going to open it this way. We have -1 and -5. -1 is bigger than -5, so we're going to open it this way. We've got -5 and -2. going to open this way. We have 0 and negative 3, going to open that way. Alright, let's use the symbols less than and greater than continue. Now we have a number line here, and we have some numbers plotted on this number line. We have a negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 3 as plotted numbers on our number line. A says negative 4 is less than negative 3 because negative 4 is to the left of 3 on the number line. This is just going over the previous examples we did here, looking at it on a number line as well. So found on the number line here, negative 4. And here we found 3. We can clearly see that negative 4 is less than less than 3 because it's further left on the number line. You can do the same thing for negative 1 and negative 5. You can find negative 1 on the number line here. Negative 1 here is bigger than negative 5. So that's why we say negative 1 is greater than negative 5. And we compare negative 5 and negative 2. So if I look at negative 5 once again and negative 2, the negative 5 is smaller than the negative 2 because it is to the left of it on the number line. Last but not least, we will look at 0 and negative 3. So if I look at 0 and negative 3, we can see that 0 is to the right of negative 3 on the number line, which is why we say 0 is greater than negative 3. The symbols less than and greater than may be combined with an equal sign, as shown in the following table. The inequality is true if either the less than part or the equal to part is true. So here it says A is less than or equal to B. Examples: 2 is less than or equal to 9, and 9 is less than or equal to 9. Both statements are true because only one part of this inequality has to be true. So 2 is indeed less than 9, so the less than or equal to holds. 9 is indeed equal to 9, therefore the 9 is less than or equal to 9 holds. We can also do it with the greater than or equal to. The inequality is true if either the greater than part is true or the equal to part is true. B is greater than or equal to A. 9 is greater than or equal to 2. This is true because 9 is greater than 2. And 2 is greater than or equal to 2 because 2 equals 2. So the equal to part is true there. Now we have something called absolute value. The absolute value of an integer A, denoted by the absolute value of A, which are those two vertical lines on either side of the A, is the distance from 0 to A on the number line. Because the absolute value describes difference and distance, it is never negative. So because the absolute value describes a distance, it is never negative. It's always positive. Let's look at some examples. We want to find the absolute value of negative 3. So essentially all that the absolute value does is turn the value positive. If the value is already positive, it just stays positive. Here we have the absolute value of 5. It's already positive, but it just stays positive. And here we have the absolute value of 0. 0 here is neither positive nor negative. The absolute value of 0 is just 0 itself. You can also look at the distance from 0 on the number line to determine these values. So we can see that the distance between 0 and negative 3 is a value of 3, and that is the absolute value. The distance between 0 and 5 is 5, so that is the absolute value, and the distance between 0 and 0 is essentially just 0 because you do not move. Further explaining the solution, the absolute value of negative 3 is 3 because negative 3 is 3 units away from 0. The absolute value of 5 is 5 because 5 is 5 units away from 0. And the absolute value of 0 is 0 because it is 0 units away from itself. Now, let's look at the addition of integers. So, first rule, it says if integers have the same sign, we will add their absolute values. And number 2, the sign of the sum is the same sign of the two numbers. So, in this first example, it says negative 11 plus negative 15 equals negative 26. In order to get this, we add their absolute values. So we add 11 plus 15, which gives us 26, and we use the sign that is common among each of the numbers because they have the same sign. The next rule says if integers have different signs, we want to subtract the smaller absolute value from the larger absolute value, and then the sign of the sum is the same as the sign of the number with the larger absolute value. So here when we look at negative 13 plus 4, that equals negative 9. How did we get that? Because we did 13 minus 4, which is 9, and then we took the value of the larger absolute value here, which was the negative in front of the 13, because negative 13 has the larger absolute value of the two numbers. Don't overcomplicate this. If you are good at addition and subtraction, don't overcomplicate it. It is just a way of defining the actual practice that we do in addition and subtraction. If we look at another example here, 13 plus negative 6, we are essentially subtracting 13 and negative 6 and keeping the value of the bigger number here. The bigger number here is the 13, and we will keep that value, which is positive, which is why we get a positive 7. Study tip. A good analogy for adding integers is temperatures above and below 0 on a thermometer. Think of a thermometer as a number line standing straight up. For example, negative 11 minus 15 is negative 26. If it is 11 degrees below 0 and the temperature falls an additional 15 degrees, it will then be 26 degrees below 0. Very cold. Negative 13 plus 9 equals negative 9. If it's 13 degrees below 0 and the temperature rises 4 degrees, the new temperature will be 9 degrees below 0. Slightly warmer, but still very cold. If we have negative 13 plus negative 6 equals negative 7, we can think of it as it's 13 degrees above 0 and the temperature falls 6 degrees. It will then be 7 degrees above 0. Let's look now at additive inverses. Additive inverses have the same absolute value but lie on opposite sides of 0 on the number line. When we add additive inverses, the sum is equal to 0. For example, 18 plus negative 18 equals 0. They are additive inverses. Negative 7 plus 7 equals 0. They are additive inverses. In general, the sum of any integer and its additive inverse is 0. The sum of a number and its negative is 0. Let's define subtraction of integers. For all integers a and b, a minus b is a plus the negative b. In other words, we will subtract b from a. To subtract b from a, we add the additive inverse of b to a. The result is a subtraction called the difference. All we are doing is defining the very things that make up mathematics here. You have been doing addition and subtraction, hopefully, almost your entire lives at this point, but maybe you never knew the definition of what you exactly were doing. All we're doing here is defining it. We are not at all changing the process. So if you are proficient at addition and subtraction, continue to be so, but now you will know the definition. Let's do some examples. Let's subtract 17 minus negative 11. Okay. Now, with this, we do have to know some rules here. So, if we look at 17 minus negative 11, we have to keep in mind that minus a negative actually turns into a positive. So what we are really looking at here is, typo here. What we are really looking at, let me handwrite it, is 17 plus 11 minus a negative turns into a positive. So 17 plus 11 is 28. Just a simple typo here. I apologize for the typo in the lecture. That's supposed to be an 11 because obviously 17 plus 18 is not 28. If we look at negative 18 minus negative 5, we are essentially looking at negative 18. Oh Lord, a lot of typos here. If we're looking at negative 18 minus negative 5, we have to essentially know that just like the problem above, this turns into a positive. This gives us negative 18 plus 5, which gives us a negative 13. This solution here is incorrect. Please ignore this solution. If we look at C, negative 18 minus 5, all we're really doing is adding those two numbers together and keeping the sign of the common sign, which here is negative. So negative 18 minus 5 is negative 23. Apologize for the typos in the previous two examples, but hopefully the handwritten work will work for you here. The last example is indeed correct. You're essentially just adding them and keeping the sign. Negative 18 plus negative 5 is negative 23. Let's look at the multiplication of integers. The results of multiplying two or more numbers is called the product of the numbers. Think of multiplication as repeated addition or subtraction that starts at 0. For example, 3 times negative 4 is 0 plus negative 4 plus negative 4 plus negative 4, which is negative 12. Okay. The numbers have different signs, therefore the product is negative. If I look at negative 3 times negative 4, essentially what I'm looking at here is 0 minus negative 4 minus negative 4 minus negative 4, which is the same thing as 0 plus 4 plus 4 plus 4, which is 12. Keep this rule in mind. A positive times a negative is a negative. So positive times a negative is a negative. And it doesn't necessarily have to be a negative 1. So let me fix this and just make it a complete negative. A positive times a negative is a negative. And a negative times a negative is a positive. You can also rewrite this first one. A negative times a positive is a negative as well. The order does not matter here. So, multiplication of integers, looking at the rules. Rule number 1. The product of two integers with different signs is found by multiplying their absolute value, and the product is negative. So if we have a negative and a positive, we wind up with a negative, or a positive and a negative, we wind up with a negative. If you have opposite signs, they will be negative. Rule number 2, the product of two integers with the same signs is found by multiplying their absolute value, and the product is positive. So a negative times a negative is a positive, and a positive times a positive is a positive. The product of 0 and any integer is 0. So any number times 0 is 0. So we have three simple rules. So if we have a negative times a positive, we have a negative. If we have a positive times a negative, we have a negative. And if we have two integers of the same sign, that turns out positive. So positive and positive give you positive. Negative and negative give you negative. And anything times 0 just turns out to be 0. Next rule. If no number is 0, a product with an odd number of negative factors is found by multiplying absolute values. The product is negative. Okay, so what we see here in the example is negative 2 times negative 3 times negative 5 is negative 30. What happens here is we essentially have a negative times a negative times a negative. A negative times a negative is a positive, which simplifies this to a positive times a negative after you do a little bit of work. And a positive times a negative we know is a negative. So if you have an odd number of negative factors here, you're going to wind up with a negative number. If no number is 0, the product with an even number of negative factors is found by multiplying the absolute values. The product is positive. So here we only have 2 negatives. 2 is an even number, and therefore the end result is a positive number. Even if you had 4 negatives, so negative times a negative times a negative times a negative, that would still wind up being a positive here because it has enough to cancel each other out. Negative and a negative is a positive. Negative and a negative is a positive. Positive times positive is positive. Let's look at some exponential notation. Because exponents indicate repeated multiplication, rules for multiplying can be used to evaluate exponential expressions. So, we're going to evaluate negative 6 squared for A. We are going to evaluate negative 6 squared for B. We are going to evaluate negative 5 to the third for C. And for D, we're going to evaluate negative 2 to the fourth. If we look at our solution here for A, this exponential notation basically means you multiply that entire thing within that parentheses twice. That's why we multiply negative 6 times negative 6. And we know that a negative times a negative is a positive, which is why we wind up with 36. Because 6 times 6 is 36. Those two negatives cancel each other out. Okay? If I look at the second style notation, with the second style notation, what I'm truly looking at here, negative 6 squared, the negative part itself is not squared. It just stays out front. So I'm looking at negative 6 times 6, which is 36. Because the 6 part is truly the only part that is squared. Sometimes I prefer to write this negative times 6 times 6. So you can see that negative is completely different from that exponent right there. It turns out to be the same thing because you have your negative outside, and 6 times 6 is 36, and negative 36 in parentheses just reduces down to negative 36. If I look at C, negative 5 in parentheses to the third, that's negative 5 times negative 5 times negative 5 because that parentheses includes that negative. Okay, negative 5 times negative 5 times negative 5 is negative 25. Because we have an odd number of negatives here. If we have an odd number of negatives, that means my final term here is going to be negative within that multiplication. These two negatives will cancel out and make a positive, but we still have this positive times this negative, which keeps the overall value here negative. If I look at negative 2 to the fourth, I'm looking at negative 2 times negative 2 times negative 2 times negative 2 4 times. So that negative is included in that parentheses, which is why we multiply it each and every time. What we see here is we have an even number of negative numbers, which means that that negative is just going to cancel itself out, and our final value here is going to be positive. Negative and a negative is a positive, so these first two negatives cancel themselves out. Negative and a negative is a positive. These two cancel themselves out. Positive times positive is positive. Let's look at the division of integers. The result of dividing an integer A by the non-zero integer B is called the quotient of numbers. We write this quotient as A divide B, where A divides B. Okay, or A divided by B. So if I'm looking at 12 divided by 4, or here in this case, negative 12 divided by 4, it can simply look like the fraction negative 12 over 4. And we know by reduction here that 12 divided by 4 is 3. We keep this negative value associated with it because there was nothing to cancel it out. This also can revert back, and we can check it by multiplying 4 times negative 3. And that shows us that we indeed did the question correct, because 4 times negative 3 is 12. Okay. We have rules for division of integers just like multiplication, and they are very, very similar. The quotient of two integers with different signs is found by dividing their absolute values, and the quotient is negative, just like in the multiplication. The quotient of two integers with the same sign is found by dividing their absolute values. The quotient is positive. 0 divided by any non-zero integer is 0. Division by 0 is undefined. So here we have a little bit different things here. So if we divide 0 by something, it's 0. But if we try to divide by 0, this by definition is undefined. So we don't really want to divide by 0. We can look up to these other examples and see here that if we have a positive number divided by a negative number, it gives us a negative number. If we have a negative number divided by a positive number, it gives us a negative number. Positive by positive gives us a positive. Negative by negative gives us positive. We have what we now call the order of operations because we have defined our operations. We want to perform all operations within grouping symbols, or parentheses in this case. Sometimes we use parentheses. Sometimes you may as well see brackets used. Those are our grouping symbols. Evaluate all exponential expressions. So some of you may remember this. This part is your P. This part is your E. Do all the multiplication and divisions in the order in which they occur working left to right. This is your M and D. Finally, do all additions and subtractions in the order in which they occur working from left to right. That's your A and your S, your PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction. So let's solve this using the order of operations. We don't have any parentheses here, but we do have exponents. Let's go ahead and solve these exponents out. There's no grouping symbols. That's why we're beginning with evaluating the exponential expressions. So if I evaluate the 6 squared here first, working left to right, 6 squared is 36. Oops. $36. 2 squared is 4. And that's how we get 36 minus 24 divided by 4 times 3 plus 1. We have to continue simplifying. Our next step here is going to be working left to right to divide 24 by 4. 24 divided by 4 is 6, and that's how we get this 6 here. Still working left to right, our next thing to do is our multiplication. So the reason we did the division first is you do division or multiplication or division, depending on which the order they occur working left to right. That division occurred first, and there were no parentheses indicating otherwise. That is why we divided first. Now, the multiplication came next, and we're now going to do 6 times negative 6 times 3. That's why we will get the negative 18 here. So this number here, the negative 6 times the 3, gives us the negative 18 here. Now working left to right, we do addition or subtraction, whichever one comes first. We have a subtraction here between 36 and 18. This gives us the... what happened? The textbook is giving me a lot of typos in their pre-described PowerPoints here. The next, or maybe they didn't. Let's look at it. What's 36 minus 18? I jumped to conclusions. 36 minus 18 is 18. Pulled a tricky one on me. So 36 minus 18 is 18. That is where this 18 comes from. So we did this to get this. It didn't just drop the 36 off. That's a confusing step if you don't know what's going on there. All it was this simple subtraction. 36 minus 18 is indeed 18. You can work it out on the side. 18 plus 1 then is going to be 19, and we are good to go with our order of operations. Now, you will have some practice problems on order of operations. I highly suggest doing it step by step and taking your time, following your PEMDAS, your parentheses, exponents, multiplication or division, addition or subtraction. Remember, work left to right, doing whichever comes first in these combinations. If you have any questions, please don't hesitate to reach out to me by email. and I hope you have a good rest of your day.